Hi, name of this chapter is triangle. In this chapter of the triangle, we will first study about different types of triangles, then we will study about what is the area of a triangle, then we will study about some special kind of right triangles and so on. So what is a triangle? You all must be familiar what a triangle is. Triangle is in fact an enclosed space of three lines. You take any three lines on a plane, and when these three lines are intersecting each other, and if not their intersection point is 1, then enclosed space made by these three lines is called a triangle. Here this is a triangle. This triangle ABC is a triangle because this is made up of three lines, and this enclosed space is called triangle. A triangle is nothing but a three-sided polygon. Also, you must have been aware that the sum of all interior angles of a triangle equals to 180 degrees. Angle X plus angle Y plus angle Z equals to 180 degrees because angle X, angle Y, angle Z are its interior angles, and the sum of all these three interior angles must be 180 degrees. There cannot be an exception to that fact. This angle A here is exterior angle. Now, there is also an exterior angle theorem for triangles. It states that any exterior angle equals to sum of two further away interior angles of the triangle. What in fact it says that angle A equals to sum of two further away angles, internal angles of the triangle, and hence A equals to X plus Z. X and Z are further away interior angles of the triangle. Similarly, B equals to X plus Y, and similarly C equals to Y plus Z, because Y and Z angle are further away from this vertex C, for which we are finding out the value of external angle. Let's solve this exterior angle theorem. For this angle A, we will first discuss. Angle A we know equals to 180 degrees minus Y, because angle A and angle Y are supplementary angles. These are on a line, these are linear pair. Now additionally, we also know that angle Y equals to 180 minus X plus Z, because the sum of all interior angles of a triangle equals to 180 degrees. Now you put in the value of Y from this to the first equation, and you get A equals to 180 minus, then in the bracket 180 minus X plus Z, close the bracket, and you have A equals to X plus Z. Similarly, you can derive the theorem for angle B and angle C. So the exterior angle theorem of triangle states that any exterior angle equals to sum of two further away interior angles of the triangle. There is also a thing called triangle side inequality. Triangle side inequality says that sum of any two sides of a triangle must be greater than the third side. Let's understand this with this example. Now, for this triangle of the three sides, lengths are X, Y, and Z, then you take any two sides together. Then the sum of this any two sides must be greater than the third side, and hence X plus Y must be greater than Z. Similarly, X plus Z must be greater than Y, and similarly Y plus Z must be greater than X. If this theorem stands true, then we can form a triangle. Let's solve a problem related to this. Now this is a triangle we have been given. The sides have been given as X, 7 and 10, and we have been asked that what can be the range of X. So let's apply this side inequality theorem. Take X and side 10 first. So X plus 10 must be greater than 7, from which we have is that X must be greater than minus 3. Okay, X definitely must be greater than 0, so this does not impart us very good information, but that's fine. Now let's take X and 7 together. Now X plus 7 must also be greater than 10, and hence X is greater than 3. Similarly, when you take line 10 and 7 together, you have 10 plus 7 is greater than X, that is 17 is greater than X. Now these two later inequalities make a compound inequality of them, and you have 17 which is then greater than X, then which is then greater than 3. So the range of X is 3 and 17. Range of X is 3 and 17. It means that the value of X cannot go beyond this range. The value of x, if someone says that equals to 1, then it cannot be. Exactly, if someone says that the value of x equals to 20, then it also cannot be. Additionally, you have seen that the value of x cannot be 3 or 17 either, because it must be greater than and not greater than or equal to. The sign used in our inequalities is greater than and not greater than or equal to. So if x equals to 3, then also these three sides can never constitute a triangle. There's also a certain relationship between angles and sides of a triangle, and it states that the interior angle of the longest side is always largest, and similarly the interior angle opposite to the shortest side is smallest. What I am saying is that understand it through this example of a triangle. Now this is a triangle. 5, 6 and 7 are its length of different sides, and now we want to write A, B, C in an ascending order. You see that what I was told, that interior angle opposite to the longest side is largest. Now here the longest side is 7, and hence the angle opposite to this side 7 is C must be the greatest among all those three. So the angle C must be greatest. Similarly, the shortest side is 5, and then angle opposite to this shortest side, that is angle B, must be smallest, and hence angle B must be smallest. Angle A then will fit in between, and we will have angle C greater than angle A greater than angle B. Now converse of this statement that we have just discussed is also true. What I'm saying is that the side opposite to the largest angle is longest, and similarly side opposite to the smallest angle is shortest. Again, understand this through an example of a triangle. Now this is a triangle, this is a right triangle. Right triangles are those in which one angle equals to 90 degrees. This is a special kind of triangle. We will also discuss it later on. Now in this triangle, one of the angle is 90 degree, one of the angle is 30 degrees, and one of the angles is 60 degrees. There are three sides, and now we want to know which side is the longest and which side is shortest. As I've told you that the side opposite to the largest angle is longest, and hence it means that the line BC, which is opposite to the largest angle 90 degree, must be greatest in length, and hence line BC must be greatest in length. Similarly, the smallest angle here is angle B equals to 30, then the side of the triangle opposite to this angle 30 should be smallest, and hence this line AC then should be smallest. AB will fit in between, and we have is BC, which is then greater than AB, and then which is greater than AC. Now let's discuss about what is area of a triangle and what is perimeter of a triangle. Formula for area of a triangle is given as 1 by 2 multiplied by base multiplied by height, or it is written as area A equals to half into B into H. Here base B can be any side of the triangle. Remember, base B can be any side of the triangle. However, height is not just another side. Height H is the length of the perpendicular drawn on the base B from the opposite vertex. For example, in this triangle, I'm taking line BC as base B, and if I'm taking this BC as base B, then opposite vertex to this base, that is A, I'm dropping a perpendicular on the base B, and then I have this line AO. Length of this line AO is height H, and then the area shell can be 1 by 2 into B by H, 1 by 2 into base multiplied by height. Remember that both base and height must be perpendicular to each other. The angle made by the lines of base and height is always 90 degrees. As I told you that you can take any line as base, and once you have decided that you are going to take this line as base, then you have to find out which one is the height. For example, let's see this triangle. In this triangle, ABC triangle, first let's say I'm taking again base as line BC. If I'm taking as line BC as base, then area of this triangle is going to be half multiplied by BC multiplied by AA. Now AA is the length of the perpendicular drawn from its vertex to the base and hence its height. The angle between the base and height is 90 degrees. Similarly, if I take AB as base, then our CC shall be the length of the height, and our area then shall come out to be 1 by 2 multiplied by AB multiplied by CC. Similarly, if I take AC as base, then our BB shall be the length of the height, and our area then shall be 1 by 2 multiplied by AC multiplied by BB. You find out 3 different areas from these 3 different formulas. In fact, these are not different, these are one and the same. Area of the triangle is same. Whatever you take the base, the area of a triangle does not change. When you change the base, the height also changes, but the area remains same. Now let's take into consideration this right triangle ABC. In this ABC right triangle, you can see if you take BC as base, then you drop a perpendicular from an opposite vertex A, and the length of this opposite length is going to be the height. And this is same as AB. So the area of a right triangle equals to 1 by 2 multiplied by BC multiplied by AB. So the height and length of one side is same only and only for a right triangle. For this triangle, you can see that again, if you take this BC as base B, then you have to drop again a perpendicular from the opposite vertex, that is A, and this height H is you get, and then you get this height H. Now the formula for this remains same, and you have the area of a triangle equals to 1 by 2 multiplied by B multiplied by H. Now, what is perimeter of a triangle? Perimeter, in fact, of anything is sum of all its sides. For a triangle, there are 3 sides, so all you have to do is that the sum of lengths of all these 3 sides is going to be the perimeter of a triangle. Now let's know about 2 different and special kind of triangles. One of them is called equilateral triangles. You know that the triangle is a 3-sided polygons. These 3-sided may be of same length in some special cases. In the case of equilateral, this is this special case. All these 3 sides are of same length. Once that all these 3 sides are of the same length, their angles, interior angles, are also same. See, ABC here is an equilateral triangle. This is an equilateral triangle, and hence length AB equals to BC equals to AC. Now, as I've told you that all the 3 interior angles of this triangle are also going to be the same. Additionally, we know that the sum of all these 3 interior angles equals to 180 degrees. So what we have is that each and every interior angle of this triangle, this equilateral triangle, equals to 180 by 3, that is 60 degrees, and hence angle A equals to angle B equals to angle C equals to 60 degrees. This special kind of triangle is called isosceles triangles. In the isosceles triangles, you take any 2 sides and the length of these any 2 sides is same. The length of the third side is not same as the 2 sides. Any 2 sides have the same length. For example, this triangle ABC here is an isosceles triangle because its length AB and length BC is same. However, the length AC is not same as AB or BC. Now, one more thing you need to know, that the angle opposite to these same length sides are also going to be same, and hence angle C, which is opposite to side AB, and similarly angle A, which is opposite to side BC, are same, and hence angle A equals to angle C for this isosceles triangle. So let's solve some problems on triangles. Now, triangle CAB is a right triangle because angle A here is 90 degrees, and we have been given that the area of this triangle ABC is X. Now they want to know what is the area of triangle ADC. So let's first concentrate over this right triangle. For this right triangle, this area is going to be half multiplied by AB multiplied by AC because it is a right triangle. And so we have is X equals to half multiplied by AB multiplied by AC. Now just concentrate on this another triangle ADC. Now for this triangle ADC, I want to know its area. The base I'm going to keep the same, that is AC. However, I want to know the length of the height. So what I'm going to do is I'm dropping a perpendicular from the opposite vertex, that is vertex D, on this base AC. Now you can see that the length of this perpendicular, that is DO, is same as AB, and hence the height is same. So the height and base are same, and it means that the area of this another triangle is also going to be same, and hence the area of this another triangle is also X. Okay, so let's solve another problem. So in this problem, this figure we have been given of a triangle, and the problem wants us to tell what is X plus Y. So let's first concentrate on this smaller upper triangle. For this smaller upper triangle, we know that the sum of interior angles equals to 180 degrees. So this particular angle then is going to be 180 minus 30 plus 90, or equals to 60 degrees. Now concentrate on this bigger triangle, and this bigger triangle again apply the same theorem, that is sum of all interior angles equals to 180 degrees. One of the angle is X, another angle is Y, and then another angle is 60. So X plus Y plus 60 equals to 180, or you get X plus Y equals to 120. So that's what the value of X plus Y is. Now the another problem. In this another problem, we have been given this kind of figure, and they want us to tell what is the value of X plus Y. See, first concentrate over this left hand side triangle. In this left hand side triangle, this angle shall be 180 minus X plus Y, because the sum of all interior angles equals to 180 degrees. So this angle here is going to be 180 minus X plus Y. If this angle is 180 minus X plus Y, then the angle opposite to it, which is also a vertical angle, in fact is also same, 180 minus X plus Y. Now concentrate over this right hand side triangle. For this right hand side triangle, we have one angle as 50, one as 60, and one angle we have is 180 minus X plus Y. Apply the interior angle theorem on this right hand side triangle, and you will have 180 minus X plus Y plus 50 plus 60 equals to 180, or X plus Y equals to 50 plus 60, that is 110.